So in this demo today, we're going to see how Iguazio and Azure together help you bring data science into production. So what I'm going to demonstrate is how you can use the Iguazio platform and Iguazio feature store, part of the Mlr project, in order to accept data from different sources, real-time, batch, online, offline, databases, and so on. The data is going to be ingested, transformed, prepared, and stored in different views, in real-time view and on offline view on Azure Data Lake. The next step that we're going to see is essentially automating the generation of the training or the models. We're going to generate an automated flow using Iguazio on top of Kubernetes that is going to go and create a data set, create snapshots, run the training in the Azure ML service, grab back the data and the models from the Azure ML service, and then take this into a real-time serving pipelines with different stages in it, ensembles, pre-processing, data enrichment, and so on. Combine it, the data and the model into that real-time pipeline. And the last step is to build tracking into that service, monitoring the models, monitoring the activities of the pipelines, monitoring the data, and writing it back into the feature store so we can retrain our models again and again. And this is a full cycle, and this is very well integrated with the different Azure ML services, the Azure ML notebooks, the different analytic tools, data lakes, and data stores in Azure, the Azure ML training and AutoML services, and other frameworks in Azure. Now let's look at a demo. The demo consists of 6 steps. First is setting the environment. The second is building those features using the feature store, ingesting data from outside. Third is creating those feature vectors that are going to feed our training process. Then we're going to launch Azure ML training process in an automated fashion. We're going to see how it's working. Then once we have the models generated by Azure ML, we're going to create serving pipelines, which consist of multiple steps, ensembles, pre-processing, enrichment, and so on. And the last step is to monitor all that activity and write it back into the feature store. So without further ado, those are the different steps. This demo is public. You can see the link. The first thing is just create some imports. Let's create a Mlr project. This is essentially a container where we're going to put all of those different assets that we're generating. Now we have a heart disease data set, just very simple, just for sake of demonstration. We want to do different transformations of that heart disease data set, which arrives from sort of a sample store. We just do simple transformations like mapping values, encoding values, and so on. This is defining the transformation pipelines for every time data arrives, whether it's real-time or batch arrival, is going to be processed with those different transformations. We could add more complex transformations and aggregations and stateful computation, etc. This is not going to make it much harder or complex. All of that is working with very nice abstractions of building those transformation pipelines. Once we build the data set, we're creating a training set or a feature vector, as we call it, which combines data from this feature, but we can combine data from different feature sets, different groups of features that are ingested together. We can view this feature vector, the composed or the analyzed data set for training just before the training. And now we want to launch an Azure ML workflow, automated ML. Usually when you do that in Azure, you have to register data sets and upload them. You have to initialize computation, start experiments, configure things, etc. So it's not going to be too hard for us because we're just going to import a pre-baked Mlr function from the Mlr marketplace. We're going to set secrets from an environment file with all my Azure credentials. We're going to load them into the project object, so they're going to be stored in a vault. So now we're going to use that Azure ML automation function, which have all sorts of different methods, but the most interesting one is just train. Just pass it some configuration, a feature vector, and then it will just generate a bunch of models based on the feature vector that we're sending. We may need to build a function, just add all the dependencies of the function into its image. Now we're going to set those parameters. We're requesting 3 models to be generated. We're setting some attributes, and we're going to run this AutoML function wrapped by the Mlr automation. So we're just going to pass it the feature vector. The feature vector is a smart object. It contains information about the labels, the target labels, about statistics of the features, and so on. So we just need to pass this feature vector by URI into the function, those few parameters. And this is where the magic starts of Mlr is going to register those, generate the data set, the materialized view of that data set. Is going to load it into the Azure Data Lake. It's going to register that. It's going to initialize computation, experiments, clusters, all those things, and then start executing the Azure ML jobs. You can see the progress of the Azure ML job as it's running. That's going to take a while, so I ran it up front, and at the end we're just going to see the total results of this job, where we generate models. The best was actually, 1 accuracy equals 1, sort of couldn't be better. And then Mlr also grabbed all those model objects that were generated in Azure ML and turned them into model artifacts that are ready for use in production pipelines, added a bunch of metadata to them, and so on. So we can actually look into the Azure ML job, and we could use some Mlr cool capabilities for comparing different runs. We could see that we have 3 different runs. These ones had different algorithms, different parameters, and so on. We can also visualize the output of the run and serve a nice parallel coordinates plot. It's very useful for examining the impact of parameters on results like accuracy. So we can visualize that. And now we want to deploy the model into production, but we don't just want to deploy a simple endpoint. We want to create a topology, create a real-time pipeline, which comprises of intercepting data, doing some pre-processing on the data, taking the data and doing enrichment. So for example, you get a customer ID or patient ID. You want to take data from the feature store that tells you all the information about that patient. This is done just by a simple definition here. We're just going to say this is our feature vector, the one that holds the mapping between the patient ID and all the other values of the patient. We may want to do imputing, which is replace missing values with some statistical meaningful values. So all that is going to happen automatically in this object of router. And then we're just going to add 3 different models and configure an ensemble. So essentially the average value of all those models is the one that's going to be returned. We can build way more advanced pipelines with additional post-processing, registering data to databases, and so on. But this is just as an example that you could build a relatively advanced solution with 10 lines of code in Python. And the next thing we want to do is just test this pipeline locally. So we generate some small data set. We can create a simulator locally. I won't do it because it requires installing all the Azure packages locally, which is a lot. But here you can just create a simulator. A developer can work against the simulator, debug his real-time pipeline. And once it's ready, the only thing you need to do is deploy this pipeline into production. In this case, we want to set the tracking, so we have model monitoring into those pipelines. And the only thing we need to do is just say deploy. Deploy is essentially taking our code, building containers, building images, deploying them as real-time services on top of a Kubernetes cluster. All that is auto-scaling and elastic. Once it's done, I can just go and test my real-time endpoint by just pushing HTTP requests with some input data and viewing the results. Now that I have all of that, I can just go into the different dashboards of the model monitoring, and view the results of the model monitoring. If I have drift, what are the accuracy, what are the actual features that are being pushed against my model, and so on.